Tonight I'm planning to do an experiment for you, one that comes from section 19.4 in our text. It deals with titrations and neutralization. The demonstration I did for you in one of our recent classes was involved with the indicators, and what I did with that 96 well plate is I put it in a plastic bag and sealed it so that I would still have it after a period of time. So let me begin with showing you some things with the titration and these indicators. First of all, let me take the well plate out of the bag, see how good that is. It's had a chance to sit in here for a while, but the color arrangement is pretty much, let me flip it over here, pretty much what we had set up some days back. And the reason for me putting it into the plastic bag was so that the liquid would not evaporate. If the liquid evaporates, you don't see the color as intensely, but it still looks very, very close to what we had the other night. When you have used indicator papers, for example, here's one determining the pH, and when you've used these types of papers in the past, you usually have some kind of little comparison chart for color, and depending upon what the color is that develops, you have an idea what the estimated pH of the substance would be. So I'm going to take one of the strips from here, and I'm going to take it and put it into a solution that I think is basic, at least that's normally what it is. I have it sitting back here. It's sodium hydroxide. Let me dip this in real quick. As soon as I put it in there, I had a color change. And now the new colors look like that. And if I compare them to the page that I have here, we're going to get a pH that's going to probably be close to the end there, a pH of about 14. And that would be what's expected for sodium hydroxide. The end product that I have is a color strip, and the colors indicate what my pH would be, but that's dependent upon the various acid-base indicators that are impregnated on this little strip. They'll make the strip, and then they put the different indicators in the different places. That gives you an idea of an estimation of the pH. Okay, now what we're going to do next is do a titration. So I'm going to pause the video for just a second so I can get rid of some of these things and then come back and show you the steps of the demonstration. The experiment I'm doing is one that you fellows would be doing in the lab normally. To set up for my titration, I'm going to set up some equipment here that you're somewhat familiar with. I've got my sports stand, and to hold some of the glassware, I have a special type of a clamp. This is called a burette clamp, and it has clamps on it. It has a place where I can attach it to the support stand. Let me do that. And these clamps are spring-loaded, so if I take a measuring device called a burette, measuring liquid, if I place it into the clamps here, it will enable me to hold that liquid without me having to hold the burette. So let me clamp that in. The burette reads from the very top, up at the very top is 0. See if I can bring that up for you. My first number at the top is 0, and then at the very bottom, our number is a 50. So this burette has a capacity of 50 milliliters. I put that in, and then I'm going to add to the burette's solutions that I've made up. And in the back here, you can see I have a couple of reagent bottles, the big white Clorox bottles, and then in front of those, I have my solution. This one has sodium hydroxide in it. I'll bring it up a little closer for you. NaOH. And the other solution I have is the acid, HCl. And both of them have come from these two big bottles. our solution storage bottles. I have another beaker that I've just labeled as waste. So as I do different steps in my experiment here, if I don't need a solution, I'll just put it in here. Now, in order to do a titration, what we're trying to do is we're trying to get the quantity of moles of an acid to match up with the quantity of moles of a base. And the reaction that this one is undergoing is a reaction between HCl and NaOH. When they combine in a perfect 1-to-1 mole ratio, so that if I'm comparing my acid to my base, first of all, the math is going to be a lot easier, but it's a much simpler type of reaction. So let me load the burettes with my two solutions. You always have to have the valve on your burette closed. These two burettes have been rinsed already, so we'll pour it in. I can use a funnel to pour my solution in. I'm actually going to overfill the burette so that it's going to be above the 0 mark, and there's a reason for that. So I've got my liquid a little bit above that 0 mark in there. That's the base. Let's do the acid. I'll put these solutions in the back here, get them out of the way. Here's our hydrochloric acid. Again, I'll overfill. A couple times that I was doing this in college, I forgot to close the valve at the bottom, and the solution goes out on the floor or on your shoe. Not so good. And this one, with the acid, is also above the 0 mark. It's overfilled. Put the acid aside. Let's clamp this. So here's my two burettes. Now, when I look at the burettes closely, down here towards the bottom of the burette, there's a little glass tip. And that tip is empty right now. So if I were to measure something in here, that glass tip would have an air pocket in it. And that's one of the reasons why I overfilled. What I'm going to do is I'm going to drain out the base solution here until I get it down to 0. And I'll do that by looking at the top here, letting the base drain into the beaker. Whoops, we have a clog. Let's see our problem. We have a little clog on the burette. Let me stop this for a second. So here's what I did while we took that little break right there. The glass tip in here had a little bit of solid residue in it, which wasn't allowing the liquid to come out. So what I'm going to do is I'll place the bottom of the burette down in my beaker and allow liquid to flow through till I get to the 0 mark up on the top. And it's working now. We're now down to my water. My solution is at the 0. Yep. And the air pocket is gone from down in here. So I just simply drained that into the waste container. Let's do the same with the acid side. Let's hope that this one is not clogged up. No, this one's empty. It's flowing. We'll bring this down to the 0. There's our mark. And we have a solution in here, which is the base in the acid, so probably we have salt water in here right now. So that's the beginnings to my titration. Now, the solution of base that I have, I'm not sure if the designation that I have on the molarity on the bottle is exactly correct. So I have to standardize the base solution before I can titrate it with the acid. And I'll show you how we do that. We take a powdered acid, and that happens to be in a bottle. The container is labeled with the name. And this is potassium hydrogen phthalate or biphthalate. I'll take a small sample of this. I'm going to aim for 5 grams. So here's our balance. I'll put my pan on. We're going to zero out the pan. And then we're going to aim to put 0.5 grams of the powder into the weighing pan. It's a nice white crystalline material. I'll just tap the scoop a little bit to dislodge some of the acid. We're at 0.31, a little bit more. 0.44, 0.48, 0.50, and we're right on the button. So this is an acid that it's powdered, but when I put it into solution with water, it will provide hydrogen ion, and so it'll enable the reaction to proceed as an acid then. So I have a beaker back here. I've labeled it potassium hydrogen phthalate, but just with the initials KHP. And I'm doing that just as a shortcut. To have to write this formula all the time here would take a little bit of time. I'll do that when I go to the board. Now, in order to do this one, I just roughly need to mix this with some water. So I'm going to use distilled water. I'm going to use about 50 milliliters of it. So I've got a graduated cylinder here. This does not have to be extremely precise. So our 50 milliliters will help us to dissolve the acid, but the extra water that's in there, that's not going to be a problem. I have about 51 milliliters. It will not affect the strength of the acid. Let's pour that into the beaker. We'll first put in our acid. We'll add our water. And then we're going to stir it up. I'll use the scoop to do that. The acid's pretty soluble, so it doesn't take too long for it to dissolve. And then what we'll do is we'll put this into a flask and titrate our base against it. So you'll see the process where I do a titration using the acid, the standard acid, as my comparison. Now, I'm going to turn this off so I can reset some things on the table here. Now, I've moved my computer up towards the whiteboard here so you can see the reaction. I have it written on the board. I'm going to point out what the formulas are. This is my potassium hydrogen phthalate, KHC8H4O4. The liquid, the solution we're going to mix it with, will be sodium hydroxide. That's NaOH. My end product will be sodium with potassium phthalate. So the formula here, NaKC8H4O4. And then my byproduct that's also formed here is going to be water, H2O. And here's how the compound begins to react. The hydrogen that is here reacts with the hydroxide that's over here. So the hydrogen is going to come from the potassium hydrogen phthalate. I'm going to just abbreviate that as KHP. The hydroxide is going to come from NaOH. And then we're going to combine the hydrogen and the hydroxide ions. So the hydrogen here, the hydroxide, they're going to come together and they will form water, H2O. I'll put that over here. The potassium and sodium potassium phthalate, that's going to be a spectator ion. That'll just simply be free ions in the solution, and we're not going to worry about those. It's the combination of hydrogen and hydroxide that are going to form the water, and that's the end product to our reaction that we want to pay attention to for the acid base. Now, I'm going to turn off the video at this point. I'm going to go back to begin the titration.